Now let's look at how to utilize Excel to solve quadratic functions. So here, first, I'm introducing utilizing spreadsheet model for quadratic function equations or functions. Here are the steps. So first, we need to set up the spreadsheet with input cells and desired outputs. And then we fill in the spreadsheet with formulas for vertex and roots. Just to remind, this is the function for vertex minus b over 2a, and for root, this long thing is that. And we create a table referencing the parameters. In the end, we can create a graph from the table. Okay, so now let's look at those examples. I'm gonna use this example that we utilized. Okay, so here we know B3 only has one solution, B2 has no solution, B1 has two solutions. Okay, it is actually the same. It is actually the same parabola, just shifting up and down. Okay, so let's see how this is done. Switch to create an Excel file. Here, what we do is first we write down the formula. X squared minus 8x plus 12. That's the formula. X squared. So here, shift the 6 means we add a power. Minus 8x plus 12. So that is the original one. And then the other functions, let's just change. We have add 20 and we have add 16. Okay, those are the three functions. All right, so now let's look at how to solve them. So here, first we need to work out the vertex. Okay, and we need to work out, say, root determinant. Okay, and then root 1, root 2. So let's look at function 1, using that as an example, which is the first one. Okay, so for function 1, we have A, B, C. Okay, A equal to 1, B equals to minus 8, C equal to 12. Okay, what is the root determinant? The root determinant is, well, B squared minus 4AC, right? Because this determines how many roots that you're gonna have. So here I just refer to this as root determinant. Root determinant. ANT. All right. So here, vertex is minus b over 2a. B over 2 times of a. That is the vertex in this case. So here, x equal to 4, the straight line should be the symmetric pivot. And then the root determinant is b squared minus 4 times of a times of c. Okay, in this case, root determinant is greater than 0. So there are 2 roots for function 1. That's the conclusion that we have. Then we can solve for the roots. So the function, the formula that we are invoking to solve for the root is minus b plus square root of, so here we need to add a square root of b squared minus 4ac, which is the root determinant. Okay. And this is the numerator, and the denominator is 2 times of a. Okay, it doesn't allow me to do square brackets, so we need to change that into the curvy, the round one. So that's the first one that we have. And here we can actually copy and paste. Okay, just copy down this and then paste. But the only thing that you need to change is plus square root. Now you need to change this into minus square root. Here we have equal to 2. That's your root 2. Okay, that is for function 1. For function 2, you can do the same thing, right? In that case, function 2, here we just copy and paste. The only thing that changes is c. C is changed into 20. For function 2, we can copy and paste the first 2 at least, right? Okay. Now we need to be watchful. We need to double check, because as you're copy and paste, sometimes the row gets changed. So here we need to make sure it is minus b over 2 times of a. Okay, and here the root determinant is supposed to be b squared minus 4 times of a times of c. Here it is smaller than 0, therefore no root for function 2. Okay, so that's function 2. Yeah, I'm gonna add a line here. For function 1, I'm gonna add a line here. Okay. So that you know we are starting from here onwards, that's function 2, and now function 3. Function 3, ABC can be copied, and C is 16. Okay, so here first we need to look at vertex and root determinant. Like you found in function 2, if you are working on the root determinant and the result is negative, then you don't have to step further to solve for the roots, right? Okay, because there will be no solution. So now For vertex, it is minus b over 2a. Which is also 4. Here, the reason is a and b holds the same for all the three functions, so the vertex should be the same. Now, the root determinant. B squared minus 4ac just equal to 0. Only one root for function 3. Okay, so now we are working out this root, which is minus b plus root determinant, which is 0. That's why plus and minus doesn't change the result. Okay. And then over 2a. I suggest that you be meticulous. Just add brackets as is necessary, as much as possible, I would say. Here, if you don't add brackets, possibly what Excel will do, like if you're doing this way, what Excel will do is to use this addition to be divided by 2 and then multiply by your F20, which is A. That's not right. Okay, so you want to make sure it's 2a, the entire thing, to be in a denominator. So just add a brackets. Okay, so the result is 4. So this is how you utilize the function. Okay, spreadsheet modeling to work out the solutions. Also, another magic that I want to show you is, like previously we have this setup. Actually, I'm just doing this step by step to show you the comparison. But say from function 1 to function 2, the only thing that changes is the term c. Actually, if you change the term c here, you should get the result automatically. Okay, and here this number exclamation tells you there is no solution, which was what we found below. And if you change your term c into 16, you only get one answer, or you get 2 roots with the same result. That's because your root determinant is 0. Plus or minus it doesn't change the result. Okay, so setting up the correct equation is of utmost importance, and later on you can play around the ABC parameters to apply this to different functional form. Say if I have a 2x squared, you can put this way, and then there can be a result as the follow. Okay, so this is the general format of the setup. That is, I would say, universally applicable to quadratic functions. Then for whatever quadratic functions that you have, what you need to do is just to change a, b, c as the function that's given to you. And the result that you found in your root should be consistent with how many roots there are based on the relative relationship with root determinant to 0. Thank you.